Okay, today we'll be talking about fats and oil. Fats and oil. And as you can see the screen, you'll see some nuts, you'll see some fruits, you'll see fish, you see oil, you see melon. All right. These are different sources of fats and oils. But before we look at these fats and oils, I want us to take a quick quiz on esters. I want us to take a quick quiz on esters. Now, I want somebody to name the alkanol and carboxylic acid that form pentyl ethanoate. If you know the answer, unmute yourself. In the next 5 seconds, I'll call names. So unmute yourself if you know the answer. Okay. Chimamanda. Chimamanda, please unmute yourself.
Yes, sir.
Thank you. Chimamanda, do you know what esters are?
Yes.
Are you sure? Hello?
Yes, sir.
Okay. Go on. Can you tell us the alkanol and carboxylic acid that form pentyl ethanoate?
I have no idea.
No idea. Okay. Okay, we are going to learn that today. Fami Roju, any ideas? Fami Roju Emmanuel.
For the first one, alkanol is pentanol.
Sorry, I didn't get that. Say it again.
For the first one, the alkanol is pentanol.
Pentanol is correct. And the carboxylic acid?
Ethanoic acid.
Ethanoic acid. Very good. Very good. That's correct. Ugoma, I need you to answer the second one. Propyl metanoate.
This is propanol and
Propanol. Okay.
yes, and
the carboxylic acid is what? A metanoic acid.
metanoic acid.
Very good. Very good. Very good. All right, you can all mute yourselves. So thumbs up for 2 of them. Everybody give them a thumbs up. Everybody. Thumbs up, thumbs up, thumbs up. Yeah, feel free to give yourselves thumbs up too. Ruth, I've not seen your thumbs up. Are you in this class? Very good. Very good. Ruth, I've not seen your thumbs up. I hope you are in this class. All right, without wasting time, let us learn how to do this real quick before we forge ahead. So, when we have an ester, to tell the carboxylic acid and alkanol that form the ester, we look at the parts of the name. Okay? We look at the parts of the name. The first part of the name tells you the alkanol. The first part of the name tells you the alkanol. So let me show us real quick. So it has 2 parts, the pentyl parts, okay, and the OH part. Okay, the pentyl part tells you the alkanol. So the alkanol in this case is pentanol. This is equal to pentanol. Sorry, my stylus is acting up. Oh, no. This one isn't working. Sorry, I need to change my stylus. Or let me just use my hand. Let me wipe this. So pentanol plus ethanoic acid. Please write that down. Ethanoic acid. Okay. Then, sorry, the D didn't appear. Then for propyl methanoate, that one is propanol plus methanoic acid. Who can tell me the natural source of methanoic acid? Methanoic acid. Yes, anybody? Give us the natural source, the origin, natural source of methanoic acid. Any ideas? Any ideas? Any ideas? Okay, methanoic acid is from bee sting. Bee sting. So when ants, even ants, when bees sting, they actually inject this acid into your body. Is that clear? So let's look at the second question. It says, write the structures of the esters above. Now, two things you need to know about the esters. You must know the alkanols and carboxylic acid that form them, and you should be able to write their structures. Now, the rule for writing structures of esters is start from the ending part of the name, the OH. You must start from the OH. Now, the OH is how many carbons? Since it is ethanoate, eth means 2 carbons, isn't it? Or ethan means 2 carbons. So we'll put out our 2 carbons like this. Okay, ethanoate. So to make it ethanoate, we'll fill in the hydrogens. We'll fill in the hydrogens. Then the OH now is what I'm drawing now, COO. This is the COO. So this is the ethanoate part. Okay, then the pentyl part has how many carbons? The pentyl part, because it is pent from the word pent, 5. Okay, so we have 1, 2, 3, 4, 5. Pentyl. So we fill that with hydrogens. Make sure every carbon has only 4 bonds. No carbon has more than 4 bonds. Every hydrogen has only 1 bond. So we fill that like that. Now this is pentyl ethanoate. And you must be very careful in writing such structures so that you don't add a bond here. Some students will forget and come and add another bond here. That is not correct. Is that clear? So this is pentyl ethanoate. That is how it is named. Pentyl ethanoate. So I want every one of you to draw propyl methanoate in your notebook, or write rather the structure of propyl methanoate in your notebook. I'm going to give you 30 seconds to do that. After 30 seconds, I'm going to write the structure on the board. I'll write the structure on the board. If you get it, if you check your notes, what you wrote, and it's the same as what I wrote, then you can reward yourself with a chilled glass of Zobo. With a chilled glass of Zobo. So everybody now, propyl methanoate. Everyone, propyl methanoate. I need to see your own. Propyl methanoate. Or rather, not necessarily see it, but write it in your notebook. You have 30 seconds. You have 23 now. If you are done, let's see who will be the first. If you are done, Unmute your microphone and say done. Anybody? Fami Rojo, are you done?
Yes, sir.
Oh, good, good. One more person, then I'll write the structure. One more person. Fami Rojo is done. One more person, and I'll write the structure on the board.
Sam.
Ekene Chimamanda, I think I heard her voice. She's done too. Okay.
I'm done.
So good, good. Okay. Looks like everybody is done. Yeah, judgment time. Let's check out what we have done and see if it is correct. So everybody get ready. Everybody get ready. So propyl metanoate, we'll start with metanoate, which is also one carbon. O, O, then H. This is the metanoate. This is the metanoate. Meth, one carbon. Methanoate. Then the propyl, prop is 3. So we'll go 1, 2, 3. Then we'll fix in the hydrogens. Fix in the hydrogens like that. That is it. This is the structure of propyl metanoate. So, how many of you are getting Zobo tonight? If you are getting Zobo tonight, I want to see your thumbs up. If you are getting Zobo tonight, I want to see your thumbs up. Only one person is getting Zobo. Very good. More people are getting Zobo. Okay, it looks like everybody is getting Zobo today. Okay, if yours is not correct, please take correction now. Okay, methanoate is one carbon, and that is it there. So let us proceed. Let me clear this. So now the objectives, what you must learn or be able to do at the end of this topic is define fats and oil. Okay, the next you should be able to explain triglycerides, glycerol, and fatty acid. You should know these 3 terms: triglycerides, glycerol, and fatty acids. You should be able to demonstrate good knowledge of these 3 terms. Then differentiate saturated from unsaturated fats. When we did hydrocarbons, we were taught saturated and unsaturated hydrocarbons. If you weren't taught saturated and unsaturated hydrocarbons, don't panic. We are going to give you a hint today. 4, describe the physical and chemical properties of fats and oil. 5, explain hydrolysis, saponification, hydrogenation, and rancidity. Okay, then of course answer WAEC, JAMB, NECO, and GCSE questions confidently. So let's move on. Fats and oils are lipids. Okay, they are also called lipids. Chemically, they are esters formed when one molecule of glycerol reacts with 3 molecules of fatty acids during esterification. Please take note of that. Chemically, they are esters. These esters are called triglycerides. This triglycerides is a special name given to fats. Okay, they are esters but they are specifically classified as triglycerides, and they are formed when one molecule of glycerol reacts with 3 molecules of fatty acids. Now, you have heard fat. You've also heard fatty acids. You must be able to tell the difference. Fats, then fatty acids, then there is glycerol. So quickly, let's look at this expression here. You see down there, it said there are 3 molecules of fatty acids. RCOOH, then there is R prime COOH, then there is R prime prime COOH. These are 3 different fatty acids. You may begin to wonder, what does R mean? And what is even R prime? And worst of all, R prime prime, right? Now, R represents the hydrocarbon portion of the acid, the hydrocarbon portion. When we say hydrocarbon portion, the part that contains the carbon and hydrogen. We are going to illustrate this further as we proceed. All right, we are going to show you different molecules of fatty acids, and you are going to see clearly what R represents there. But it is very important to know that when fatty acids react, this is their functional group. Chemical reactions for organic compounds usually occur around the functional groups. So this is glycerol, but glycerol has 3 OH groups. And remember when we did alkanols, we said alkanols with 3 OH groups are said to be trihydric. They are trihydric alkanols. So glycerol is a trihydric alkanol, and each of these functional group on glycerol will react with one fatty acid, and you see what the reaction results to. It gives an ester linkage there. Then another one, this one, will react with this on the same glycerol, and you see a new ester linkage. Then this separate acid again will react with the third OH on the same glycerol, and it will give you this. Now, that R that you are looking at there is a long chain hydrocarbon, which is usually, it can have up to 7, 12, or even 15 carbon on a chain. Pay close attention. I want to illustrate something. I want to explain something very, very crucial here. The difference between fat and oil is here. The difference between fat and oil, what makes fat, fat, and what makes oil, oil, is on that R. And that is where we say saturated and unsaturated. Shortly, you are going to see what that means. The reaction between fats and oil, the reaction between fatty acid and glycerol produces fats or oil, and it also produces water, as you can see in that equation there. So let's look at glycerol. Let's look at each of those items separately. Glycerol, C3H8O3, is a trihydric alcohol containing 3 hydroxyl groups. So let's have a closer look at glycerol. Now, this is what glycerol looks like structurally. All right? 3 carbon atoms, 3 OH groups, and in total, it has 8 hydrogen atoms. I hope this is clear to everyone. Now, fatty acids. Again, if you look here, we are expressing fatty acids with R. We are expressing fatty acids with R. What did I tell you that R is? Chimamanda, what did I say R is?
Sir, you said that R is a hydrocarbon compound.
A hydrocarbon chain, not compound. Okay? The entire fatty acid is the compound. R is just a hydrocarbon chain. Is that clear? It's just a
Yes, sir.
hydrocarbon chain, which is part of the entire compound. So let's move to can you still see my screen?
Yes, sir.
Can you all see my screen?
Yes. Yes.
Okay.
Yes, sir.
Okay. Okay. So now let's look at a typical fatty acid now, not fat. You are looking at the fatty acid. This is palmitic acid. Can somebody count and write on the chart how many carbons are on palmitic acid? How many carbons do we have? Send the chart. Count real quick. It will be doing you sickle in your eye, but you have to count one by one. How many carbons are on palmitic acid? I'm waiting for your charts. Nobody yet. Okay, nobody yet. Okay, before it gives you headache, because I know some of you will count and recount again. There are 17 carbon atoms on palmitic acid. 17 carbon atoms. Now, still on that chart, I want you to tell me if palmitic acid is a saturated fatty acid or an unsaturated fatty acid. Is palmitic acid a saturated fatty acid or an unsaturated fatty acid? Somebody? Okay.
They're saturated.
Okay. Somebody is saying they are saturated. Do we all agree that palmitic acid is saturated? Is there anybody in this class who does not know what saturated and unsaturated mean? I will explain it all the same. I will explain it all the same. I hope you can all see the palmitic acid. Okay. Now, the palmitic acid is saturated. And what saturated means is that there are only carbon-carbon single bonds. There are no carbon-carbon double bond or carbon-carbon triple bond. Any hydrocarbon chain that has only carbon-carbon single bonds is said to be saturated. And one that has carbon-carbon double bond or carbon-carbon triple bond is said to be unsaturated. All right, good. So this is for palmitic acid. So let's quickly look at the differences between fats and oils. Saturated fatty acids have only single carbon-carbon bonds. And these are called fats. They are called fats. They form fats rather. They form fats, while unsaturated fatty acids contain one or more carbon-carbon double bonds. Carbon-carbon double bonds. And these unsaturated fatty acids form oils. They form oils. So let's quickly look at this. This is oleic acid. You may be wondering what all those lines mean. But we are going to look at these lines because These are going to be common sites, especially when you go into the university. This will be very, very common, especially for those who are going to do biochemistry, chemistry, pharmacy, medicine. You are going to see these. Okay. Now, what does this mean? Let's not get confused when we see it. Every corner has a carbon. So let me write it there. Sorry, I want to write that properly. Every corner has a carbon and it has a hydrogen, or two hydrogens rather. Okay, so this corner here also has hydrogen and hydrogen. So this corner also has hydrogen, carbon, then hydrogen, hydrogen, and so on and so forth. But when we come to corner here, where you are seeing those lines, this one has carbon and carbon. Those double lines means double bond. Are we together? They mean double bond. So this will be hydrogen, and this one will have only one hydrogen. So that's a double bond. Now, because of the double bond there, when you see this kind of structure with two lines anywhere like this, double bond mean that there is unsaturation there. There is unsaturation there. So oleic acid, I want somebody to unmute themselves to tell me, is oleic acid a saturated fatty acid or unsaturated fatty acid?
Unsaturated.
Okay, somebody thinks oleic acid is saturated. Anybody with a contrary opinion?
I said it's unsaturated.
Okay, unsaturated. Okay, somebody thinks it is unsaturated. Any contrary opinion? Okay, none. So yes, it is unsaturated. And the reason why it is unsaturated is because it has this double bond right here, like we learned earlier. So quickly now, let's look at other ones. Palmitic acid, we said is saturated, and the reason why it is saturated is because it has only single bonds, no double bonds. So let's look at differences between fats and oils now. Differences between fats and oil. So fats are solids at room temperature, and oils are liquid at room temperature. Fats are solid at room temperature, and we must be able to explain why. Now, listen attentively. The reason why fats are solid at room temperature is because the long chain hydrocarbon portion of these fats have only single bonds. And these single bonds allow for rotation and flexibility between the carbon atoms. This flexibility and freedom of rotation allows the molecule to pack. Okay, and when all these molecules spiral and pack like that, they form a solid. But that is not the case with double bonds. Double bonds reduce the degree of freedom, the freedom of movement. So the atoms that are involved with the double bonds, the carbon atoms that are sharing the double bond have restricted movement, and they cannot spiral, they cannot spin between each other and actually pack as easily as fats will. So the double bond actually keeps them long and lanky. So they will stay long and lanky, and because of that, they remain in their liquid state at room temperature. So with this explanation, you can see that those oils that are rock solid at room temperature, that are rock solid, very hard at room temperature, are most likely completely saturated. Completely saturated. Then there are some that we'll find some oils that when the weather is somehow, just a slight adjustment in temperature, they will solidify. Those ones, they have multiple bonds, but they are not, their multiple bonds are not so much, all right? They have moderate multiple bonds, and that is why at some temperature, a little bit lower than room temperature, they begin to solidify. Now, if there is high degree of unsaturation, multiple bonds abound along the hydrocarbon chains of the fatty acid portion of the lipid, we are going to see that it is going to be oil and not fat. So it's important to know that fats are solids at room temperature because of the flexibility between in the movement between carbon atoms, which allows them to pack together. But that flexibility is not enjoyed or is not experienced so much in oils, and that is why they remain liquid at room temperature. Again, second differences. Fats are mostly of animal origin. Please take note of the point of the word mostly, not all, mostly. Then oils are also mostly of plant origin. Of course, there are some oils that are from animals, there are some fats that are from plants, okay? So, but mostly we can use their origin to classify them. Fats are mostly of animal origin, while oils are mostly of plant origin. Now, fats are saturated, while oils are unsaturated. What that means is that fats are formed by the esterification of glycerol with saturated fatty acids, 3 saturated fatty acids. In the case of oils, oils are formed by the esterification of glycerol with 3 unsaturated fatty acids, because it's the saturation of the fatty acid that will determine whether what we will get would be fat or oil. Then, of course, due to their state at room temperature, we know that fats have higher melting point while oils have lower melting point. So I don't know if anybody has a question. Feel free to ask, please. If you have a question, if you can't ask verbally, you can type it in the chat before we move on. Any question? Okay. There are no questions, I guess. Okay, no questions. When I fire my own, make sure you are make sure you be ready to answer. Okay, now let's look at differences between fats and oils. We are looking at them structurally. Okay, now first let's look at the reaction. The reaction. You will see that the fatty acids here, they are all saturated. You see the glycerol, don't mind the spelling there. I think that is, I don't know, glycerol. Glycerol. So, that is glycerol. Then look at the fatty acids. You see that, like I said earlier, they are saturated. Now they are going to esterify. Please take note. You need to understand what happens during the esterification. You need to understand what happens during the esterification. During esterification, this is what leaves. H from the alkanol and OH from the acid. H from the alkanol and OH from the acid. Isn't that ironic? It's supposed to be H from the acid, isn't it? But of course, it's OH from the acid. This will help you to remember. Now, again, H from this alcohol and OH from the acid. As you can see, these will cut out to form the water. Okay, this is where the bonds break to form the water. So this will give us 3 molecules of water, 3H2O. Okay, this will give us 3H2O. Now, this one will bind directly to the other. Let me change this color to show you. This carbon will now bind directly to this oxygen. This one will bind directly to this oxygen. And this one will bind directly to this oxygen. And that is what gave us this now. That's what's giving us this ester linkage. This ester functional group is as a result of the binding of the CO residue from the acid to the O residue of the glycerol. I hope this is clear to everyone. In a case where you are asked to write the equation for esterification of fatty acid and glycerol, here it is. All right. So this other part is just the hydrocarbon part of the fatty acids. And like I said earlier, remember, don't forget, this is the part that tells us whether it is oil or fat. Okay. And don't forget that they might not be of the same chain length. Their chain lengths might be the same, they might be different. And that is why we use R, R prime, and R prime prime. So when we are talking about R prime, sorry, my stylus is misbehaving. R prime, and R prime prime. Okay, this is now what we are referring to. In this case, in this example illustrated here, the R prime and R prime prime are exactly the same, okay? Because they are from the same fatty acid, all right? But there are cases where they are from different fatty acids, from different, what do we call it now? From different, with different hydrocarbon chain, all right? They can still form the fat, all right? And it will have its own texture and its own behavior. So I hope this is clear to everyone. The esterification of glycerol with fatty acids to form fat. Now, differences between fats and oils. See, which of these will have the highest melting point? I want somebody to unmute himself, tell me which, and give me his or her reason. I'm going to label them A. So oleic acid is A, linoleic acid is B. Okay, then alpha linoleic acid is C. Then gamma linoleic acid is D. Then E is there as docosahexaenoic acid. Docosahexaenoic acid. So I'm waiting for you. Which of these will have the highest melting point and why? Okay, I think I'm going to call names now. Chibueze Chikamso. Chibueze Chikamso. I don't know which part of this class you missed, but I think I want you to answer this. So unmute yourself quickly. Chibueze Chikamso. Is Chibueze with us, or he just entered Zoom and went to play game? Chibueze, if you are with us in this class, unmute yourself. Okay. While Chibueze is still playing game, Chimamanda, unmute yourself and tell me what you think.
So I think the answer is E.
E. Can you read the question again and tell me why your answer is E? Yeah? Why do you think it is E?
Uh,
Yeah, we are waiting for you to tell us why it is E. You have to choose the option, then tell us why you choose that option. No idea?
yes, sir.
Okay, so what you do is listen and learn, okay? Listen to be sure to see if you are correct and learn.
Okay, sir.
Okay, so who is okay, Famiroju Emmanuel. Famiroju, let's hear you.
I think it should be lake acid.
Hmm? I didn't hear you.
I think it's A.
You think it is A. Okay, so tell
Yes,
us why you think it is A.
it has one double bond.
It has only one double bond.
Yes,
Okay, and that means its level of unsaturation is the lowest. Or we can even say it is the most saturated of them all, isn't it?
yes,
Okay, I think that is correct. That is correct. Ekene Chimamanda, do you understand that?
Yes, sir.
Are you sure you understand it very well?
Yes, sir.
Okay, if you understand it very well, I want you to tell me which one will be the next after that. If A has the highest boiling point, which one will have the next after A? Second highest.
B.
B, very good. Very good. Indeed, you understood it clearly. Thank you very much. So thumbs up for them. Thumbs up, thumbs up, thumbs up. Thumbs up, thumbs up, thumbs up. Uh-huh. Uh-huh. Root. I'm not seeing your thumbs up. Oh. Uh-huh. Very good. Thank you. Good. Good. So let's proceed from here.
So can I ask a question?
Yes, please do.
The numbers on the diagram, does it have a specific function?
Yes, but not for your level. Okay, not for your level. This is actually when you are studying fats. As a matter of fact, nobody is going to ask you to write the name of the fatty acid, oleic acid, linoleic acid. No, no. At your level, all you need to do to show that it is fatty acid, as soon as you just do the zigzag, just come to the end and do COOH. That's all. In fact, this is even acceptable. RCOOH. But in that case, it's very important that you state what R is. Tell us that R is a long chain hydrocarbon. Simple. Okay, so the numbering now is for an advanced chemistry and is not for you. I just picked it up from one of my one text like that. Yeah, I think, yeah. Picked it from my text just for the sake of illustration. So you may just forget about the numbers for now at this level, okay?
Uncle, I also have a question.
Yeah, do ask, please.
That thing, okay, beside the red one, on top of the red one, what
Just
is that?
leave all those things, okay? Leave all those ones. They are not for you now. Okay, they are not for you at this level. Both the numbering and those gamma and gamma, alpha, and all those, just forget about those ones. you have no need of those. So if you wrote the structure with those ones, please ignore them. Don't cancel, but just ignore them. Just know that it's not an information that you must have at this level. Is that clear? If I'm to explain it, I'll have to start teaching you the naming technique for fats. And that's not what we need to be learning at this level. I hope you understand that.
Yes, sir.
Good. Okay, now physical properties of fats. They are insoluble in water. They are soluble in organic solvents such as benzene, such as kerosene, and all that. If you put fat, tallow, if you get tallow, that's the fat from cow, right? From cattle. If you collect this tallow, if you throw it into kerosene, it will dissolve. But if you throw it into water, it is just going to float. Why does it float? It floats because it is less dense than water. That's item number 4. Remember that oil floats on water, and that's because water is denser than oil. Then they are greasy. They are greasy. Okay, they float on water. They burn with smoky flame. They burn with smoky flame. Now that burning with smoky flame, you may know or may not know that in ancient cities, maybe if you watch some movies that are depicting ancient cities, you see that there are some sticks they hang on the wall. Okay, there are some sticks they hang on the wall, and there are people that actually come to light those sticks at night so that people that are passing will see. We are in modern time where solar powered street lamps are just lighting up everywhere. In the olden days, it's even in the ancient city, maybe in the capital city even, that you will see such lamps available. And those lamps are actually either fabrics. They are fabrics that are soaked in animal oil, animal fat, okay? Usually from whales or large aquatic animals or any other animal, or from pigs, okay? So just fats from animals, they'll soak them on that fabric and light it up at night, okay? Used to be a very important. Having oil is just like oil for us now. I mean crude oil now. So oil is very essential then, because that's how you have light in your house. So they actually burn with smoky flame, but their flames are luminous. Their flames are luminous. I'm just trying to connect you to flames, luminous flames. So chemical properties, the first one is saponification. Ugoma, can you read what saponification is?
Saponification. This is the alkaline hydrolysis of fats and oils to produce soap and glycerol.
Very good. Very good. The alkaline hydrolysis of fats and oil to produce soap and glycerol. By alkaline hydrolysis, we mean that the fat and oil is hydrolyzed using alkaline solution. The alkaline solutions in this case are sodium hydroxide or potassium hydroxide. Okay, now what does hydrolysis mean? Who can tell me, what does hydrolysis mean? When they say you have hydrolyzed something, what does it mean? What does it mean to you? Yeah? No idea. Okay, hydrolysis means to break down, okay? It's the art of breaking down a large molecule to smaller molecules using water, acid, or alkaline solutions. Okay, what did I say hydrolysis is? The breakdown of large molecules, maybe polymeric molecules, or in this case, fat, which is a macromolecule. We break it down into smaller molecules using water, using alkaline solution like sodium hydroxide or potassium, or using HCl. All right. So here we are looking at alkaline hydrolysis. So we are doing it with sodium hydroxide or potassium hydroxide. Now, triglycerides, which is fat or oil, will react with sodium hydroxide or potassium hydroxide, any of the two, to give us soap and glycerol all mixed together, soap and glycerol. It is typical for students at this level to make soap in their school, okay? So, it will be fantastic if you're able to make it in your school. It's going to help you produce soap for your home use so that you won't be buying soap anymore. But please, before you start doing that, before you offer to help your family or support your family by manufacturing soap for them, make sure you have equipped yourself with the technique very, very well, so that you don't go and peel your family's skin and say it's uncle that said you should start making soap. All right, make sure you have learned the techniques, you have learned the recipe, the measurements, you can get them accurately. Then it's very easy. It's very easy. Everybody should know how to make soap. So this is a typical reaction, as you can see there. The triglyceride, you'll see there, in this case, is fat, because the chain appears saturated. CH2, CH2, CH2 means it is saturated. Okay? So that is fat there reacting with sodium hydroxide. Okay? It's reacting with sodium hydroxide. So this is fat from palmitic acid. Fat from palmitic acid being hydrolyzed by sodium hydroxide to form glycerol and sodium palmitate. To form glycerol and sodium palmitate. Now, that sodium palmitate is a soap. Soaps are usually salts of fatty acids. Salts of fatty acid. I want you to look at this. Salt of fatty acid. Look at that sodium there. You see that if you compare it to the fatty acid, sodium is just replacing hydrogen on the fatty acid. And of course, the replacement of sodium, the replacement of hydrogen by a metal on an acid forms salt. What I mean is, if you've got a metal and you replace the if you have an acid, and you replace the hydrogen of the acid with a metal such as sodium, what you form is salt. So take note. Soap is the salt of fatty acid. Soap is the salt of fatty acid. In this case, is sodium palmitate. Another common one you will see in exams is sodium stearate. Sodium stearate. Sodium stearate is going to come from stearic acid. That means the fatty acid that formed the fat is stearic acid. So when it gets hydrolyzed with sodium hydroxide, it forms glycerol and sodium stearate. But in this case, we are using palmitic acid. I hope that is clear to everyone. Is it clear to everyone? Now, let's look at this very important thing. When soap is made, we're also going to talk about it, because after this, in our next class, we are going to do soaps and detergents. Okay? When soap is made, the soap and the glycerol are mixed together. They are mixed together. So when they are mixed together like that, you can use it as toilet soap for taking your bath. Okay? You can use that for taking your bath, because glycerol is a very powerful humectant. Okay? It is hygroscopic. That's what I mean now. It is hygroscopic. It will absorb moisture from the environment to keep your skin soft. Okay? It will absorb moisture from the environment to keep your skin soft. That's one of the uses of glycerol. It makes your skin soft. But when laundry soap is intended, what happens is that salt is added. Salt is added to the soap batch, to the soap mixture. All right? And that will reduce the solubility of the soap. So the soap will float on, and down we are going to have glycerol, which can be tapped out. All right. So if you add salt to the soap batch, because it will form something like paste, okay, a flowing paste. All right. When you add salt to it, it's going to separate the soap from the glycerol, so you can remove your soap. Now that one is for laundry, because your laundry does not need absorption of water. So you will want to separate the soap from the glycerol. So in industries, they will sell the glycerol separately as glycerin, okay, while the soap is sold separately as laundry soap. Take notes for laundry soap. Good. So that is that here. Then let me clear this. So let's look at the other chemical property is hydrogenation. Hydrogenation, in this case, it is oil that we hydrogenate. Hydrogenation is the addition of hydrogen across the double bonds. And remember, it is oils that have double bonds. Now, when you hydrogenate oil and you turn all the double bonds to single bonds, you would have converted the oil to fats. Are we together? You would have converted the oil to fat. What are the conditions for hydrogenation? Okay, you need nickel as catalyst. Write that down. Nickel is the catalyst for hydrogenation reaction mostly. Okay. Okay. So when the unsaturated oil is hydrogenated with nickel as catalyst in the presence of at temperatures at about 170, 180 degrees centigrade, we are going to get fat. That means we are going to end up with a solid starting with liquidy oil. All right, we are going to end up with a solid fat. And this process that I've just described is the process involved in the manufacture of margarine. Okay? This is what is applied in the manufacture of margarine. Margarine is hydrogenated vegetable oil. Hydrogenated vegetable oil. It will now be fortified with some other nutrients, a little salt, a little this, a little that, okay? But basically, margarine is manufactured by hydrogenation of oil. It is the hydrogenation of oil that hardens the vegetable oil to form the fatty substance that we eat as margarine. I hope that is clear. Now, the other chemical property we must know is oxidation. Oxidation. Oxidation of fats or oil will cause rancidity. Okay? Rancidity. It will give it bad taste and bad smell. The oil will begin to behave, will begin to taste somehow. You know, some of you may have experienced it with palm oil. When you buy palm oil in bulk and you allow it sit for a while, the palm oil will begin to have some stickiness, sticky taste on the tongue. Then over time, the smell will begin to become unpleasant. It will become unpleasant as it does what? As it's exposed to oxygen and it gets oxygenated or oxidized rather, not oxygenated, oxidized in this case. I hope this is clear. So let's look at the uses of oil as we are rounding up. Let's look at the uses of oil. We are going to answer some questions today, and you are going to screenshot the questions, write me your answers, and send. Then I'm still going to give you a night quiz that you are going to do again this night. This night. You must answer the quiz this night. So uses of fats and oil. Culinary uses for cooking. All right. We use oil, fats in baking. We use margarine in baking. We use oil in frying. We use palm oil in cooking. So generally in cooking, we need oil. Then oil is one of the raw materials for manufacture of soup. All right. Margarine is also made from oil. Cosmetics, many of them are made from oil. Of course, soap is part of these cosmetics. Pharmaceuticals, lubricants, candles, biodiesels, energy storage, even in our body, protection and insulation. Protection and insulation, where you want to insulate or cover a piece of iron or a metallic substance. In the olden days, when they use their hoe for farming, when they are done farming, okay, after the farming season, after the harvesting and everything, they clean off, they wash off the sand on their hoe, and they use animal fats to cover the metallic part of the hoe. And this is to prevent interaction between the iron and moist air, which could lead to rusting. So by way of protection, they grease it. They grease it with oil. When they grease it with oil, they now store it for another planting season. All right. So these are some of the very many uses of oil. Now, let's look at these common exam tips. These are some things you need to know about fats and oil. Fats and oils are esters. Remember that. They could trick you. Okay? They could trick you. Which homologous series does fat belong to? Then you now start wondering, nobody mentioned fat when we did homologous series. So remember now that fats are esters. Fats are esters. All right? Then glycerol is a trihydric alkanol. Remember that. Glycerol is a trihydric alkanol. Hydrogenation converts oils to fats. Remember this. So this is one of YX favorites. They'll just write oils. They'll put arrow. Then they'll write fats. Okay? Oils. They'll write fats. They'll now ask you, name the reagent for this reaction. The reagent is hydrogen. They'll say, name the process. That process is what now? That process is hydrogenation. They will say state 1, or they might even say state 2 conditions for that reaction. First condition, nickel as catalyst. Second condition, temperature of about 180 degrees centigrade. They might even go ahead to ask you state 1 industrial application of that process. State 1 industrial application of that process. An industrial application of that hydrogenation of oil to fat is in the manufacture of margarine. Remember that. Manufacture of margarine. Then also remember, in case they begin to bring some tricks with chemical proceedings, and they say something like one test tube contains oil and the other one contains fats, okay? And they put bromine water in the tube and shaken vigorously. You should predict what will be observed in the 2 test tubes. I want somebody to unmute their microphone and answer that question. I want somebody to unmute their microphone and answer that question real quick. I'm going to ask the question again so that everybody will get it. A test tube contains oil. Another test tube contains fats. Bromine water is added to the 2 test tubes and shaken vigorously. The 2 test tubes were shaken. Both of them contain bromine water, one with fat, the other with oil. Now, the question is, state what will be observed in the 2 test tubes. Yes. Hello. Okafor Kenechukwu. Okafor Kenechukwu, I asked you a question. You ran away. Oh yeah, now answer this one. Your network kicked you out, shey?
So I was not here.
You weren't? I thought you were the one I was asking question at that time that eventually disappeared. Okay, that means you are not even here at all, and we thought we were seeing you. Okay, can you answer this question? Did you get my question?
No.
Okay, I said a test tube contains oil. Then another test tube contains fat. Hold on, at what point did you join this class? Because it might be unfair for me to be asking you questions for something that you didn't learn.
5 minutes ago.
5 minutes, don't worry, mute yourself. Mute yourself, don't worry, sorry. Why did you come late? Why did you come late? Ruth, I need you to answer this question.
The fat
Okay.
might float on top of the bromine water.
Okay. And the oil?
Then it will decolorize the water.
Which one?
The oil.
The oil would decolorize the water. All right, I want us to go a little bit deeper. Now, why does it decolorize the bromine water? Also. Ruth, you ran too early. You ran too early. Why does it decolorize the bromine water?
I don't have an idea.
Okay, so hold on. Let me get your answer right, because it's very important you learn how to answer questions correctly. Remember, I said state what will be observed in the two test tubes. Okay, what will be observed in the two test tubes. So what will be observed in the fat test tube is that there will be no change in the color of the bromine water. But in the oil test tube, the bromine water will decolorize. The bromine water will decolorize. The reason why the bromine water decolorizes is because oil is unsaturated. Remember, bromine water is used to test for saturation. Is bromine water you can use to test if a hydrocarbon is saturated or unsaturated. Unsaturated hydrocarbons will decolorize the bromine water. Saturated hydrocarbons will not decolorize the bromine water. So if we take it back to hydrocarbons, alkanes will not decolorize bromine water. Alkenes will decolorize bromine water. Why? Because the bromine will attach themselves around the double bonds, okay, to form a compound that is colorless. Okay, when the reddish brown bromine attaches to the double bonds, okay, when they attach to the double bond, across the double bond, the compound that is formed, the dibromo alkane that is formed is colorless, and that is the reason why the orange color disappears. I hope everyone is clear with this. So if you are asked such a question, make sure, since they are asked to state the difference or the observation in the two, you state that in the fat, there will be no visible change in the reddish brown color of bromine, whereas in the oil, the reddish brown color of bromine will fade or decolorize. Are we together? Due to the unsaturation in oil. I hope that is clear. Then finally, soap is produced by saponification. And we define saponification as the alkaline hydrolysis of fats and oils. So it's either fat or oil to produce soap and glycerol. To produce soap and glycerol. So I'm going to give you some I'm going to give you some questions to answer. So everybody screenshot. Everybody screenshot. You are going to send the answer to this night. I'm still going to post MCQ questions. That's multiple choice questions, CBT. Okay? I'm still going to post CBT that you will answer this night. So we will have something to study through the night. Okay, something to use to regurgitate and go through everything we've done today and consolidate our knowledge to ensure that this stays in our head. Is that clear? So I need everybody to screenshot this, screenshot. Define fats and oils. 2, explain hydrogenation of oils. Then 3, differentiate saturated and unsaturated fats. Number 4, describe soap manufacture. Describe soap manufacture. Then number 5, state 5 uses of fats and oils. So I'm sure you must have done your screenshot. Any question? Now, that one is the one you are going to do this night. So this one is the part A for this night's work. Like I said, I'm going to send part B of this night's task. So this is your assignment. Now, usually how we do assignment is you make sure you submit the assignment before the next class. All right? You submit assignment before the next class. But I will encourage you to do the assignment, if possible, this night. If not possible, tomorrow morning, early tomorrow morning. Okay, you do the assignment. It's best to do your assignment when the knowledge is still fresh. Okay, it's not when the knowledge has gone rusty in your head and you can't even remember much. You can start scribbling 1 or 2 for assignments. It's best to do it when the knowledge is still hot and fresh in your head, especially when you have done extra research around that topic. So this is your assignment. Any question on that? Okay, so right now we have in the neighborhood of 10 minutes. I want us to use these 10 minutes to discuss what we have learned today, ask your questions, and I will also allow you, because you're in SS3, I will allow you to ask questions from anywhere in chemistry. Anywhere in chemistry. Okay? So I'm going to... So feel free to ask questions from anywhere in chemistry. Okay. So unmute yourself. Feel free to unmute yourself and ask questions now, please.
Okay. So I'm having the electrochemical series.
Electrochemical series. Okay, you want to ask a question from the electrochemical series.
Like, I need the full outline of that electrical. That's the part that is always giving me issues whenever I'm answering all these questions.
Oh, okay. Under electrolysis and the reaction of metals and all that reaction of hydrogen.
One that is more reactive. Yes.
Okay. Now, the truth about electrochemical series is that the electrochemical series is more complicated than what you are seeing, than what you are seeing in your textbook. It's a very large series. It's a very big series. Very, very huge. But I'm going to give you the basic ones you should know for your WAEC and NECO. Are you ready?
Okay.
So for the cations, you should know K, N. Okay, no, I think this space will not be enough. Let me start from... Okay, let me do it this way. Or I can still do it there. Just reduce the fonts. So for the cations, I'll put it K. N A C A M G A L Z N F E S N P B H. So this is the one that is not metal. After H, you now have Cu, you now have Hg, you now have Ag, then you now have Au. Okay? This is the basic you need at your level. Okay? These are the ones you need at your level. Now, if you now go to some textbooks, you are going to see lithium appearing somewhere. You are going to see on some reactivity series. On some reactivity series, you are going to be seeing, what do we call it now? On some reactivity series, you are going to be seeing carbon appearing somewhere. Okay, now the reactivity series or electrochemical series, like I said, are similar. If it is a reactivity series, then you are just comparing the reactivity of metals, okay, especially for extraction or how they react with acids. If it is electrochemical series, okay, that one you are looking at, you are arranging them based on their electropositivity or electrical conductivity. Are we together? So what I've given you now is the electrochemical series, basic electrochemical series that you must know. Some of them might not even contain mercury. Some of them might even come here and have platinum. Do you understand? Some might not even contain tin or lead. So it doesn't matter. It depends on what the textbook is trying to explain, but these are the ones you should have. Okay? So you can use an acronym. You can do Kentucky Nice Chicken, Mazit, Port Harcourt, Chaga. Don't follow my own, do your own. I'm the one that knows this kabash. This kabash, I just kabash now, is my own, is me communicating with my own spirit. So try to form your own, okay? So you can come up with an acronym, but Mazit works it for me in this case, where instead of F here, I use I because it's ion. Okay, then T for tin. This is tin. SN is tin. Okay. So just pick out what works for you. But this is it for cations, which is the one that is mostly discussed. Then for anions, may go with OH minus. We deal with the common ones. OH minus, then I minus, then Br minus, then Cl minus. Then we now have NO3 minus. Then we have SO4 2 minus. Then we now have F minus. So that's the anion series now for electrochemical series for anions. Okay. I don't know if this answers your question, but these are the basic ones you must know, because these are the ones that come out as far as WAEC, NICO, and JAMB is concerned. We are not doing A level. If we are doing A level, we are going to include some other ones. Okay. So, any other question? Sorry, have I answered your question, Okafo?
Yes, you have answered.
Oh, good. Any other question, please? Please, this is your chance. Chemistry question. Make sure, in fact, make it a duty. make it a duty that every time you are attending this online class, you have a question to ask. You cannot come into class with full knowledge unless you are not studying. If you are studying, something will challenge you somewhere. And when you are coming to class, make sure you have one question that you are going to ask the teacher, because I expect that I'll be answering like 7, 8 questions at the end of this class. Okay? But if you didn't prepare your questions for this class, don't forget in the next class. You have another subject tomorrow, I think English. So come with questions. Study before the class. Do small study before the class. Pack your questions. You understand? For those that are proactive, you have your questions ready so that anytime you catch any English teacher, that English teacher must, you understand, must do something for you. I will not let you go until you bless me. Okay? So any teacher you catch anywhere, fire your question. That is how you get, that's how you get work done. I didn't say if you see a teacher in the market buying Obey, buying Obey, you now say they should go and start discussing chemistry with you. You'll be on your own. So any question, anybody, any other person with questions? There's still chance, we still have a little more time.
I did not hear what you said about that bromine water. Can you just come again?
Bromine water.
When you said you should shake the 2 test tubes.
Okay, from the beginning of the class, we said fats are saturated, oils are unsaturated. Okay? And we said, in fact, that the difference between fats and oil is on the hydrocarbon chain end. So if the hydrocarbon chain end is saturated, I may have to go back to that so that you will relate more easily with what I'm saying. So if the hydrocarbon chain length has only single bonds, we say it is saturated. Okay? If it has only single bonds, we say it is saturated. If it has double bonds, this one, you can see the oleic acid, forget about the numberings there, okay? You see that oleic acid has a double bond somewhere here, okay? Now that double bond means that oleic acid is unsaturated, okay? It means that oleic acid is unsaturated. But if you look at palmitic acid, this one is showing the full structure, showing all the bonds and all the atoms. You see that there is no double bond anywhere. So palmitic acid is saturated, okay? Now, coming to the bromine water. If you put bromine water in this, if you put bromine water in this, or bromine, reddish brown bromine in this, and you put bromine in this too. Now, bromine is reddish brown. When this bromine comes in contact with this fat, though this is the fatty acid, not the fat itself, I'm just using it to illustrate. I hope you understand that. There's a difference between the fat and fatty acid. Fatty acids may react with glycerol to make fat. It's part of the things we learned today. So if this combines with this, it will remain reddish brown. Bromine is reddish brown. But when this reacts with oil, okay, this pi bond here will break. There will be one bromine here and one bromine here. So the unsaturation will go. The double bond there will disappear. It will become single bond. Now, this product that is formed is colorless, meaning that the reddish brown color has disappeared. Are we together? When the bromine that has the reddish brown color gets engaged in a reaction by way of addition, this is addition reaction, halogenation specifically. When this happens, the product that is formed is colorless. And as a result, we say that the bromine has lost its color. So we say the bromine decolorizes, or we say the bromine changes color from reddish brown to colorless, okay? But that will not be seen here because there is no addition reaction taking place here. So the reddish brown color will still remain there. I hope that answers the question. Let me know if you understand it.
Yes, understood.
Good.